Hey everyone, Justin here with CoordinateSharp, and in this video I'm going to be showing you how to calculate sunset, sunrise, and a couple other cool solar properties in CoordinateSharp. So to get started, the first thing you're going to want to do is head over to your NuGet package manager. I'm using Visual Studio. You might be using a different developer environment, but it will be the same regardless of how you download it. You're going to go to NuGet. You're going to get CoordinateSharp. I'm not going to download this because I already have it installed, but this is the package you're looking for. Don't worry about CoordinateSharp Magnetic unless you're planning on playing around with the magnetic field data. Next thing you want to do, we're going to go ahead and add our references. Now in this application, I'm just doing a basic console app. It's the universal application that all .NET developers understand, so it makes sense just to demo it with this type of technology. So to get started, we're going to create a basic coordinate object. Everything in CoordinateSharp revolves around the coordinate object. It's really easy to use. It takes one line of code to initialize. So we'll go coordinate equals new coordinate. And we're going to set a latitude, a longitude, and a date time. Now, this expects a signed latitude and longitude. There are ways to initialize based off of other format, longitude and latitudes as well. You can also initialize off of military grid reference systems, UTM, and other formats as well, but we will talk about that in another video. For now, let's just go ahead and put in some random coordinates here. So we'll just say we're at 48 degrees latitude and a minus 122.3 degrees longitude. And then we need to set a date time for this coordinate. And we're just going to go ahead, I'm going to say datetime.now. And right now it is March 28th at 6 p.m. approximately. Just so you kind of get an idea, I'm in the Pacific Northwest USA. We're kind of around that sunset time right now. So the next thing we want to do is display our sunrise and sunset values. So all we have to do is go to our coordinate object. We're going to tap into the celestial info property, and then we're going to display our sunset and our sunrise. So let's go ahead and play this real quick. And as you can see, we have a sunset at 2:32 a.m. and a sunrise at 1:57 p.m. Now that probably sounds incredibly odd to you, and it is because CoordinateSharp operates in universal time. And the reason for that is because this software is designed around mission planning software, flight planning software. And when you're communicating with people in other time zones, everyone needs a standard time that they communicate. So they tend to use universal time. However, we can convert this to local time. Now I had the sunset on top originally. I actually put the sunrise on top. I just switched that to make it a little easier to read. So we are currently in the Pacific Northwest at minus 7 UTC. So if I want to run my coordinate object in local time, all I have to do is set an offset. And there's many ways to calculate your offset in the system. I'm not going to get into that in this video. So for ease, we're just going to go ahead and set it manually. So I'm saying we're minus 7. We'll go ahead and play this. And there we go. Now we have a sunrise at 6:57 a.m. and a sunset at 7:33 p.m., which is dead spot on for this area that we're calculating. Now, a couple things that you should note, and these are really important notes. The sunrise and the sunset property, if you look, they're actually nullable date times. So this catches a lot of people at first when they're always expecting a value and they don't get one. The reason it's nullable is because this works on a day of basis. So if there is not a sunrise or a sunset on that specific day, it will tell you there is none. It's not going to go look for the next one in the future. There is ways to do that in CoordinateSharp, which we can cover in future videos. But for the sake of this, you need to understand you might not have a sunrise or a sunset, especially when you're in the northern hemispheres, when it might be up all day or it might be down all day. In certain areas of the world, when the solar cycles in spring start expanding, there's going to be a point where you will miss a sunset or a sunrise, especially when you're operating in universal time. So that is really important to note. But what's really cool is CoordinateSharp will actually tell you what is happening that day with the sun. So it's another data point you can check besides just seeing if it's null. You can see why it's null. So we'll go ahead and check our sun condition. And in this instance, we should get a value of both sunrise and sunset. So let's type this in. We'll go ahead and start up our application. And you can see the sun condition. Hey, we have a rise and a set. If the sun were up all day, it would tell you up all day, down all day, rise only or set only. And you can also do this with lunar conditions as well if you start kind of experimenting on your own of what this library can do. So it is really important to make note of that and tap into that as needed. Another really cool feature is that you can actually see if the sun is up or down based on the date you pass. So if this is a live application where every minute you're refreshing the coordinate and you want to see if the sun is up or the sun is down for that person, you can just tap into it and then it'll tell you, and then your program will do whatever it wants to do. It's just a quick Boolean value. So a great example of usage of this is in video games where they're using augmented reality or map data, and they want the map to shift to a nighttime look, or they want their augmented reality to shift to a nighttime look as soon as that sun goes down. So basically every minute they check this bool value. Hey, once the sun goes down, we switch to night mode. Once the sun goes up, we go back to day mode. So let's go ahead and knock this out. And I messed this up here. Sorry about that. Sometimes I get confused talking and programming at the same time. All right, cool. And we can see that the sun is still up here. That is correct because it's only 6 p.m. and the sun doesn't set until 7:30. Now, there are a lot of really cool values to play with in the celestial infant class. You can get your moon illumination, your moon phase. You can actually determine when the next solar eclipse is going to be, when the equinoxes and solstices are at the exact minute. So definitely play around with this. There's a lot of cool information, and it really does take minimal code. Now, if you get deep into CoordinateSharp and you start using it in production, there are some performance implications that you probably want to look into, and you can see those on the CoordinateSharp website under the performance tips section. There are ways to make CoordinateSharp work a little bit faster for you once you determine what needs you have for it. So with that, I just want to say thank you for your time and happy coding.